Welcome to our Cartographer's Field Guide. Today, we are exploring the climate of Rajasthan, diving deep into atmospheric physics and regional classifications. Let's establish our foundation. Weather is a short-term atmospheric phenomenon that is constantly fluctuating. Climate, however, is a long-term regional phenomenon, strictly determined by a 30-year average of weather conditions. Looking at Rajasthan, the Tropic of Cancer passes directly through Banswara, dividing the state into a northern temperate zone and a southern tropical zone. Notably, 61% of the state is characterized by arid desert coverage. Rajasthan's climate is influenced by 8 distinct climatic drivers. These include latitudinal location, distance from the sea, height above sea level, and the location of mountains. It is also shaped by the distribution of land versus water, oceanic currents, the direction of winds, and upper air circulation. However, the absolute primary driver tying all of these together is temperature. Geographically, Rajasthan can be divided into 5 general climatic zones based on rainfall. The western desert is split into an arid zone receiving 0 to 20 centimeters of rainfall, and a semi-arid zone receiving 20 to 40 centimeters. Moving east, the Aravalli range falls into the subhumid zone with 40 to 60 centimeters. Finally, the eastern plains are humid, and the Hadoti Plateau and Mahi Basin are very humid, receiving up to 120 centimeters of rain. Beyond general rainfall, geographers use 3 distinct scientific models to analyze this same geography. Koppen's classification is primarily based on vegetation, along with rainfall and temperature. Trewartha simplifies this by focusing primarily on rainfall. Finally, we have Thornthwaite, whose model is based on temperature, evaporation, and rainfall, and is considered the most authentic and precise classification of the region. Looking through Koppen's vegetation lens, we find 4 zones. BWHW represents the tropical arid northwest, featuring low-density thorny xerophytes. BSHW is the vast semi-arid steppe region, known for short grass and high livestock rearing. CWG covers the subtropical subhumid eastern plains, characterized by dry deciduous vegetation, highly fertile soil, and dense populations. Finally, AO is the tropical humid savanna found in the southern Vagar and Hadoti regions. Trewartha streamlines the map into 4 rainfall-dependent zones. The tropical arid BWH region receives about 10 centimeters of rain, while the semi-arid BSH region sees 30 centimeters. The subtropical subhumid core zone receives roughly 70 centimeters, defined by hot summers over 21 degrees Celsius. The tropical humid AO zone tops the charts with 100 centimeters of rainfall. Under Thornthwaite's highly precise model, Rajasthan is divided into 4 complex zones. ED designates the dry, arid megathermal desert of Jaisalmer and Barmer. DBs marks the winter dry mesothermal region of the north. DAV is the largest climatic region in the state, spanning the desert, Aravalli, and plains. Lastly, CAV represents the subhumid environments of the Vagar and Hadoti regions. While the acronyms change, the underlying geography remains constant. Whether you call the extreme arid desert BWHW under Koppen, BWH under Trewartha, or ED under Thornthwaite, these scientists are simply using different variables to describe the exact same 10 cm rainfall environment. Rajasthan's atmospheric cycle is defined by 4 distinct seasons. Summer, from March to June, brings severe thermal extremes. During this time, the northwest experiences the Loo, hot, dry advective winds that dramatically increase temperatures. Bikaner is prone to Bhabhulya, dust cyclones, while Ganganagar averages 27 days of convective dust storms that ironically help decrease surface heat. The peak of this extreme heat hits in June, with Churu registering as the hottest district. The rainy season, from June to September, is driven by the Southwest Monsoon. The Arabian Sea branch arrives first around June 25 but yields minimal rain due to a lack of physical barriers to trap it. It is the Bay of Bengal branch, arriving as easterly winds known as Purvai, that contributes the vast majority of Rajasthan's 57.5 cm annual rainfall. This rainfall is strictly governed by geographic boundaries. The 25 cm isoheight line divides the western desert into arid and semi-arid zones, while the 50 cm line perfectly tracks the Aravalli range, separating the western desert from the eastern plains. As October and November arrive, the monsoon reverses course and withdraws. This withdrawal drops atmospheric humidity but increases ground temperature, resulting in a sudden, extremely uncomfortable spike in sensible heat known as Kartik heat. Finally, winter settles in from December to February. During this time, the western disturbance, carried by the jet stream, brings Mawath. These winter showers provide 10% of the state's annual rainfall and are celebrated as golden drops due to their immense economic benefit to the rabi wheat crop. Simultaneously, icy cold waves can drop temperatures below freezing, with Churu often registering as the coldest district in January. We leave you with the core rule of atmospheric physics. As temperature increases, air pressure decreases. In January, low temperatures create high-pressure isobars reaching 1019 millibars in the north. Conversely, in the intense heat of July, low-pressure systems take over, dropping to 997 millibars in the Jaisalmer and Bikaner regions. Understanding this pressure gradient is the key to understanding the winds, the weather, and the ultimate climate of Rajasthan.